And here, all that remains is to test if the user's input contained in the response is all digit or just the letter Q. And when the response is valid, this response is not valid. This variable is updated to be false, to create this inner while loop testing the validation of the user's input. And how can we test if the user's input contained in response is all digit or just equal to the letter Q? And here is the little Python code we used. And here we can use this regular expression just like we did previously to describe the possible patterns in Python. And this RE module we imported at the beginning of the program was for this specific purpose. For the regular expression patterns, we can use both basic and extended regular expression operators to check if the user's response to a question contains at least one digit and nothing but digits. The regular expression pattern is in here. And if their response is to quit, and the regular expression pattern is to test if the response is just a Q. And as the single regular expression, this whole pattern, which can test if the input is the digits or it's just the key Q. Here is the whole regular expression we used in this case. And we will use a single function from this regular expression module to search for valid input characters from the user's response with the regular expression. And this regular expression pattern and the strings that is compared must be specified within double quote strings. And the result of this search function call of the imported RE module returns either a match object when there is a match, which always be a Boolean value of true, or the Python value none when there is no match. And we can test whether there is a match with a single if statement. Similar to the while loop, the condition of the if statement can be described as the synced expression as long as it evaluates to a true value. And finally, the translation of valid user response is complete. And we can move on to the last chunk of pseudocode to translate the check correctness of user's response. And we can always test if the user's input is made up of only digits by using a string method. And in Python, the string methods are somewhat similar to the functions, and they are specifically designed to test for certain arrangements of characters only for strings. And methods in general, such as string methods, are invoked the same way as how the functions of modules are used by the dot notation. And the method is appended at the end of the object it is applied to, with a period character separating the object specification and the applied method. For the master program, the string method is digit, is decimal, and is numeric. It's convenient to test for only numbers in a string depending on the context. And when invoking a string method, the object is either a literal string or a variable containing a string. For example, we can invoke it on the user's response, like response.isDigit. To respect the problem statement, the isDigit method returns true when all characters in the string are numeric digit characters and there is at least one character false otherwise. And the if statement with the Python keyword or can be used to test for either valid condition for the user's input when they give a numeric answer to answer the math question, or when they want to create the program. So therefore, we no longer need to import the IE module. That is, we can omit the line import RE, which is in the beginning of the our original math tool program. So the last pseudocode chunk of Matthew is a comparison of the user's valid response to proceed in the program. They can quit anytime or receive an appropriate message based on their answer to the generated math question. And the only tricky part left is how to compare the user's response, which is assigned to the string, to a solution, which is always be an integer. And if you want to compare numeric value, they must be the same data type if you want to literally compare them based on the numeric context. The trick is to use the Boolean function, which is the int. And this function can convert string of digit characters to an integer. For example, this int string 1, 2 will be evaluated to be 12. And this string 1, 2 and string 3, 4 will be evaluated by using this int function as 12 and 34, and the sum of this 12 and 34 will be 46. And the symbol plus, which will be the addition for the integers in this context, means something very different from the string. If the string 1, 2 and string 3, 4 were not converted to the integers, this string 1, 2 and string plus string 3, 4 will be the concatenation of two strings evaluated as 1, 2, 3, 4, which is a string instead. And you won't be wrong if you thought of it just as a sticking together strings. And the translation of the user's answer to the generated math question is therefore the final line of the legal Python code. And Python is strict to its syntax, keywords, and operations. If you typed the program correctly, you should have no syntax error, and if not, you may find some at your attempts to execute the program. Python is highly sensitive to space intention. It's always required to indicate logical structure within the programs. And you need to pay attention to the number of intentions for each line. And anytime a traceback or an error message appears, you should find that line in the program code and fix the mistake. If the program runs, it is not necessarily correct. You need to test the program with many different types of input, like successes, failures, validation, and try to make it full. The particular program has one error by its design. It will occasionally generate a division by 0, such as 6 divided by 0. And the solution you are probably expecting to enter is either the number 0, which is incorrect mathematically, or undefined, which is unacceptable as input anyway. But what does your program accept instead of correct input? So fixing this division by 0 error requires redesigning the program by debugging your program. Included them as the sanity checks and consistency checks to reduce the number of thematic errors you might encounter. You will need to revisit the generation of math question, in particular how the division problems are created. So for an upcoming assignment, you will need to update the divisor, but for only the division questions, such as it will never be 0 before the solution is created in the division chunk. So when you're developing any program, you should remind yourself that the potential audience, your end users, might do something to crash or disrupt you or your seemingly perfect program. Errors are likely from your program whenever they are prompted from the input, when they might specify command line arguments for the program, or whatever else they go wrong. So more code means more changes to make an error, or and more places for potential bugs to hide. And sometimes there are multiple ways to do something in Python, such as validating input. For this situation, stick to a convention you easily understand, and to the other conventions whenever appropriate for the design of your programs. And instead of reviewing every line of your program from top of the bottom to file, you should review chunks of the code in sections. So look at the middle of the program, not the middle of the whole program code, but the general places where it will be easy to put a debugging check such as a simple print statement or a quick if statement to test a simple condition. For example, it is helpful to place checks before the loop is entered or when the loop code block begins, or you can put the checks after the loop is exited or when finish one loop is complete. And here is other two situations that you can place the checks. And these checkpoints will help track if any bugs occur in your program before or a certain point of the program execution. And to reduce the amount of time you spend testing and editing efficiently, it is a good idea to test programs with a sample of expected input. And in the future, input your program will be from various objects other than the keyboard, such as files that may be larger than file size. For example, created test files to contain only what is necessary for development is a great way to gradually debug. And errors can be hard to debug when it involves space, such as when your program is required to read and write files. And regardless of the character being a single space, a tab, or a new line, the space character are normally invisible. And fortunately, the built-in function like repre accepts any object as an argument and returns a string representation of it. For the string, all space characters, other than those typed with a spacebar key, is represented with their respective backslash sequence. So basically, here is our context today, and in the next class we will talk about some details about the Python programming.